don't understand that problem. Barely.
Now comes the hard part. Well, it's not really hard, but most people make it hard.
Maybe it's just a teacher. Trigonometry.
Oh, goody.
Here,
Yeah, it's quiz time.
calculus over there.
It is definitely not quiz time.
It's 217.
Yeah, it is.
It's 2:17. I got time. Trig functions defined on a unit circle. So, first up, unit circle.
What about it?
Pi over 4, pi over 3.
Here's 1.
What?
Oh,
Don't listen to her.
it's definitely-
1, 0. 0, 1. Negative 1, 0.
Oh, I remember this.
0, negative 1. Great.
Glad you got
Except
it.
I don't teach everything on the unit circle. I only teach a few things on the unit circle.
Oh, well, I don't remember all of it.
What is the equation of this green circle that is centered at the origin and has a radius of 1? Equation of the circle in terms of x and y.
X squared plus y squared equals 0.
Close, no cigar.
Equals c squared.
And c in this case is equal to
1.
1. So this is x squared plus y squared is equal to 1. That comes in handy later. Knowing what the equation of the unit circle is. Now, it's called a unit circle because its radius is literally a unit, 1. When we define trig on a unit circle, we define it in such a way that if we have this angle, the coordinate of the point that I run into is literally cosine of theta, sine of theta. The coordinate that I run into in terms of x and y is cosine theta and sine of theta. So on a unit circle, the x coordinate is cosine of theta, and the y coordinate is sine of theta. Now you gotta be careful.
You can make those up.
No, I didn't. You gotta be careful.
Mix those up.
These two equations that I just wrote down only work if this equation is valid. If x squared plus y squared equals 4, these two equations are not workable anymore. That 4 would throw them off. It has to be equal to 1. The radius of the circle has to be 1. So the x-coordinate of our points on the circle can be relabeled as cosine of theta, and the y-coordinates of our circle can be relabeled as sine theta. But it has to be a point on this circle.
Okay.
Does that make sense?
Yes, it does.
Okay.
Wait, what?
Wait, what?
She's trying to
What did
digest
you
it.
mean by the, it has to be a one point circle?
It has to be a point on the circle. I can't be over here and say, this coordinate is sine theta, cosine theta. Or cosine theta, sine theta. It doesn't make any sense because it's not
So
on
any point on the circle is cosine.
theta, sine theta, depending on the central angle
It
theta.
can't be in. It can't be inside the circle.
It has to be on the
Yeah.
circle. On the circle. So I know a few things. I know if I type or write in cosine of pi over 2. Now, for those that weren't here the other day when we were teaching radians, where's pi over 2?
360.
Oh, no.
Gave him a heart attack. Gave him a heart attack.
She moved the 2 up.
I read it as
270,
2
it's
pi.
3
I
pi.
read it as 2 pi.
That is definitely not 2 pi. So this is 90 degrees, and the cosine of 90 would be the same as looking at this coordinate way at the top of the picture. Now, at the top of the picture, the coordinate is 0, 1. So the cosine of 90 has to be the coordinate of the first
Which is 0.
one, which is 0. So cosine of pi over 2 is 0. It literally equates out that way. Literally. So what about sine of pi over 2?
She's definitely one.
It's going to be 1 because that's the second coordinate in 0, 1. So cosine is the first coordinate, sine is the second one. What about sine of pi?
It's going to be 0.
It's going to be 0. What about the cosine of pi?
-1.
Negative 1. Because pi is way over here, and the first coordinate is cosine of that angle, and the second coordinate is sine of that angle. So it makes it kind of easy. Now, for my purposes, in this picture, generally I only worry about the 4 points. I don't worry about the ones in between. Some people make you memorize them. I don't get into all that. So what can we do with this? Well, we can do a lot. We can find out some other angles.
It's quiz time.
Yep.
Really? I got a few.
Oh, I didn't say anything.
Let me just find one more angle.
Her cough gave me away.
Like, off.
Dear Lord.
I didn't even call.
Let's say I have a line y equals 2x. I have a line y equals 2x. And I have a unit circle. How would you draw y equals 2x?
You don't.
You do. How would you draw it? Y-intercept is?
By the way,
I don't know.
0.
0, the
And
origin.
then the slope is 2.
Slope is 2, so you go up 2 and over
1.
1. Now remember, this thing is a unit circle, so I'm going 1, 2 up here, and then over 1. So this line is going in this direction. I'm not worried about going backwards. I'm just talking about the first quadrant here, first quadrant. So if I could find the coordinate of this point, where this circle is x squared plus y squared is equal to 1, I could find the sine and cosine of the angle formed by 2x.
Yeah, can you
Okay.
just repeat all that?
Repeat what part? I just said, if I have the line y equals 2x, and I have a unit circle on my picture already, and I draw the line y equals 2x, the y-intercept is 0, so it starts at the origin. The slope of it is 2. Rise over run is up 2 over 1. So I just draw one.
Oh, wait, I just drew myself.
Now, how would I find this intersection between the green line and the blue circle? What do I know? Well, I know y equals 2x, and I know x squared plus y squared is equal to 1. So what can I do? It sounds like a constraint and an objective. The constraint is y equals 2x. The objective is the other one. So what can I plug into this one?
You can plug into that one y.
squared.
I can change y into 2x.
Squared.
So this becomes x squared plus something squared is equal to 1, and that something is 2x. Be careful, when you square 2x, it's actually 4x squared. So 4x squared plus 1x squared is
5x squared.
5x squared equals 1. How do you solve for x?
X divided by 5, and then take the square root.
And you get equals 1 over the square root of 5.
What?
Technically plus or minus. Which one do I take though?
You take the
Plus, because I'm looking for a point that's in the first quadrant. So it's plus. How do I find y now?
Put that in.
Do I plug that back into this?
No, you plug it into
That one.
To that one. So y is just going to be 2 times this one. So y would equal 2 over the square root of 5. I would leave it like that. You can write it rationally, but...
Yeah, I was going to say.
Where did I get what? If x is equal to 1 over square root of 5, y is equal to 2 times that. Because the line is y equals 2x. So what is the cosine of this angle?
Cosine is your x.
So it would be
1 over
1 over square root of 5. What is the sine of this angle? And you're done. Ta-da.
So cosine
Is the x-coordinate on a unit circle, and the sine is the y
Why would
coordinate.
you ask
Quiz
quiz time?
It is quiz time. What? What?
It's break time.
Because I was explaining that the y-intercept was 0. Ooh, turn this off.
All right, I think we'll do that. Kill him.
You're probably thinking about him, weren't you?
I thought
Well-
you called him.
We take the
Well, yeah, we take the AC
I heard.
tomorrow, so
Yeah, that's great.
we might be a little bit
Little
late
late.
for class.
Yeah.
I think I'm probably gonna be absent.
No, you won't.
Not really.
Nope. Won't let you.
Alright.
All right. So what we covered last time was trig functions only on a unit circle. And I just wanted to go through that really quick again. So if we have this unit circle,
This is just review.
Yeah.
it's not bad.
Don't write this down or do you? Yes.
If you remember it, great. If you don't remember it, that's not good. This is the general picture for the unit circle that you do need to memorize. You do need to memorize at least this much of the picture of the unit circle. It is the only way to calculate out 0, pi over 2, pi, 3 pi over 2, and 2 pi for our trigonometric functions. All the other methods I'm going to come up with will not work on those angles. So if we're dealing with sine, cosine of 2 pi over 2 or pi or 3 pi over 2, you have to use this picture. There is no other shortcut around it. We also talked about defining the trig functions based on the angle, central angle of this circle. And we talked about how this coordinate has to be cosine of theta, sine of theta. That's how we're defining our cosine and sine. Based on the angle of opening from the initial side to this terminal side of theta. These coordinates are cosine theta, sine theta. And the equation of this unit circle is, if you remember?
X squared plus y squared equals 1.
X squared plus y squared is equal to 1. So basically, that's all you need to know about a unit circle, because everything can come from this nice equation. If you know what x is, you can always find y and so forth and so on. Obviously, 2 cannot be x, because if x is equal to 2, it's way too big. It'll go over 1, and therefore you have to choose numbers like 1/2, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, things like that. We'll get to that later. I also talked about a simple example. For instance, if you have a line.
You are talking gibberish right now.
Not yet.
Yeah.
Then you flip it. Whenever flip it, okay.
We're talking about if we had a line intersecting a unit circle, we should be able to find at least sine theta and cosine theta. So I was going to come up with another line today. So for instance, what if we have the line y equals 1/3 x? And I want to know what sine of theta and cosine of theta when this line hits the unit circle. So you have another equation, which is x squared plus y squared is equal to 1. This is called a system of equations, 2 variables. So what do?
You
Plug it in.
Plug what in?
You plug y
You take the 1/3 x and plug it in
to y.
into y over here. So you get x squared plus something squared is equal to 1.
Not something, 1/3 x.
Well, x over 3, I'm going to write it out.
Okay, x over 3.
So x over 3 all squared is?
X squared over 9.
So you get x squared plus x squared over 9 is equal to 1.
And it becomes like, I guess, like 3x squared over 9 is like 4x squared over 9.
What's it become?
4x squared
No.
over 9.
No. This becomes 9x squared over 9, and 9x squared plus 1x squared over 9 is better known as 10x squared over 9. Common denominator, all that fun
Oh, I'm
stuff.
sorry, I'm stupid. 10x squared over 9.
Guys,
It becomes x squared equals 9 over 10.
9 over 10.
And then the square root,
So x is equal to,
the square root of 9 over 10.
which is better known as,
The square root of 9 over 10.
you can't keep a fraction underneath the square root.
The square root of 9 over the square root of 10.
And the square root of 9 is 3.
how
So-
in the heck does it turn into 10x squared?
Oh, common denominator. If you have a 9 in the bottom here, you need a 9 in the bottom over here. And to do that, it's 9 over 9. And 9 plus 1 is 10. Or if you wanted to go
Why did I
way
think it
back,
was
1 and
3?
1/9, and then change it into an improper fraction.
Huh?
So it has to be the positive one, right?
Yeah.
Because we're in the first quadrant, and x has to be positive, so does y. How do I find y?
Plug in x again.
Plug it in over here? Nah,
No.
right
Yeah,
in
you
here
plug
over
it
here.
in there.
Yeah. So this would be y equals 1/3 of that answer, which is 3 over the square root of 10. So y is equal to?
Wait. 3 over 3 squared is 10.
Which is better known as
1 over the square root
1
of
over the
10.
square root of 10. Alright, so this point on the unit circle is 3 over the square root of 10, 1 over the square root of 10. Technically, you're not supposed to leave radicals in the denominator, but it gets messy if you get rid of them. I mean, this one is 3 square roots of 10 over 10, and this is square root of 10 over 10. It just gets more writing. They're perfectly fine if you want to leave them that way. So after all that's done, what's sine of theta equal to?
Sine of theta is 1
1
over
over
the square root
10.
of 20.
1 over the square root of 10.
Yeah.
And the cosine of this angle?
3 over square root of 10.
3 over the square root of 10.
How'd you get 1 over the square root of 10?
After plugging in 3 over square root of 10 into this linear equation, it's 1/3 of 3 squared over 10. So the 3's are going to
Cancel.
cancel, and you get 1 over square root of 10.
They don't
Poof.
do
No, they don't go
this.
poof. That's inverse function.
I
They
still
just
don't
cancel.
understand the poof.
The poof, I can't say cancel because cancel is our shortcut for inverse identity. I don't want to say that for inverse functions.
So he just says,
So I say poof as a shortcut. All right, there's one other function that we have to define, and
Why?
why not? So over here we get x is equal to, on the unit circle, x is equal to cosine of theta. On the unit circle, y is equal to sine of theta. And if you ever get confused between those two, it goes alphabetical order. X to y, C to S.
OMG.
Yeah, OMG, oh Lord. Then there is this thing called tangent of theta. And tangent of theta is literally just y divided by x.
Or
Slope. Or slope.
sine over cosine.
Or sine over cosine, yeah.
Sakatoma.
Well, we're getting there. We're getting there. All right, so tangent is a third function we could define. There are 3 others. They're not super important because all they are reciprocals of the ones we're seeing. There is, related to the cosine, the secant.
Why would should we need to know this
Yes.
right now?
Yes. The secant of theta is the reciprocal of cosine of theta. If it's the reciprocal of cosine of theta, instead of x, it's equal to 1 over x, reciprocal flip. So this is 1 over x. Guys, you going to talk all class? You're just going to... Sine's reciprocal is cosecant, CSC. This will be 1 over y or 1 over sine. Either one's perfectly fine. And tangent, of course, is cotangent, which is x over y or cosine over sine. Cosine over sine. Now these x's and y's, you have to remember, are on the unit circle. They cannot just be any old place. It doesn't make any sense unless it's on a unit circle. Unless you can have x squared plus y squared equaling 1, don't even try using those coordinates. Because it has to be on a unit circle.
I know.
Alright, I thought you said y.
No, I said whoa.
Oh, whoa.
Like I was confused. I forget what y squared.
I was confused. Alright, so that defines them at least on a unit circle. How exciting. What I want to do is get it off the unit circle because unit circles are only good for what I consider the 4 corners. 1, 0, 0, 1, -1, 0, and 0, -1. Other than that, I don't have you memorize all the possible coordinates around this thing because they get kind of, well,